Let's build our first truth table. We're looking at this expression here. How do we read this? Well, inside the brackets, and this rule is the same in Boolean algebra as it is in regular algebra, we're going to be looking inside any brackets first. Inside these brackets, we have A plus B, which of course means A or B. So when we look at our three inputs, we're going to be determining first what the output is for A or B, for an OR gate. And then A or B is being multiplied by C. Multiplication, that's an AND gate. So once we determine what A or B is, we'll look at what happens when we run inputs from A or B and C through an AND gate. First thing we need to do, of course, is sort out how we deal with three inputs. So this is where thinking of writing zeros for half of each input and ones for the other becomes quite helpful. So we've got 8 options, 8 combinations, because 2 to the power of 3 is 8, and we have 3 inputs. So the first half of the 8 inputs will write zeros for A, and the second half will write ones. Now we'll just focus on the zeros for A, and for B, half of those zeros will also be zeros, and the other half will be ones. Same thing if we're just focusing on the ones for A. Half of the B's will be zeros, and the other half will be ones. Moving on to the input of C. So this has nothing to do with what we have previously. We're just making sure that we're writing out all possible combinations of A, B, and C in ones or zeros. So looking at the previous column where I've got 2 zeros, well, one of those zeros gets a 0 from C, and the other one gets a 1. Same thing for the ones, and so on. So this just ensures that we've represented all possible configurations. Okay, so what did we say we had to do? Well, A plus B is, of course, A or B. So we'll figure that out here. So what do we need to look at? Well, we're not at all interested in C at this point. We're just looking at A and B and determining what we've got. We're just looking at the inputs from A and B and determining the outputs for an OR gate. Remember that OR means one or the other, or both. Go ahead and fill in the ones and the zeros. Great. Now we know what A or B looks like. Now we need to know what A or B and C together. Great. Now we know what A or B looks like. Now we need to know what happens when we take A or B and C. So those are the only 2 columns we're going to look at to find the outputs for this final expression. So an AND gate means that both inputs must be 1. So when C and A or B are both 0, we have a 0 output in our AND gate. Try filling out the zeros and ones for this column. And there we go. We've built our first truth table. I mentioned order of operations with the previous problem and that we do brackets first, but let's have a look at all the other operations we could have. Like regular algebra, we'll look at brackets first, but the remainder are strictly Boolean operators. So once we've looked inside brackets, then we'll evaluate our NOT gates, our AND gates, then our XOR gates, and your very last step is to evaluate any OR functions. So with those brackets, we're going to work from the inside out. And if you're not super comfortable with the order of operations to begin with, it's helpful to write them down and then apply brackets so that when you look back at your original problem, it's easy for you to remember what order to do them in. I have to say, this mnemonic doesn't really work for me. So maybe you can think of your own. Let's try this with 2 examples. Let's build truth tables for the following 2 Boolean expressions. What's going on here? Again, we have 3 inputs. So we'll start by filling in that portion of the truth table. And maybe you've noticed that this is actually just counting from 0 to 7 in binary. You think of the 3 inputs as binary numbers. Okay, what do we need to find out first? Well, our order of operations tells us we have to deal with brackets first, then any NOT gates, AND gates, XOR gates, and finally any OR gates. So I'm going to focus inside of these brackets. What's going on here? Well, we have our regular C, but it's negated. So we will certainly do that one first, because the other option within these brackets is the plus sign or the OR. So we're most interested in negating the C first. After that, we'll take the negation of C or B. Let's try those now. The negation of C is pretty straightforward. We simply look at the C column and flip each digit. Great. Now to determine not C or B, which columns do we need? I'm only interested in not C and B. What does OR mean? It means one or the other or both. As long as we don't have a 0 in both B and the not C column, the output will be a 1. So we've evaluated not C or B, and now we need to find its negation. So it's the negation of not C or B, and that one's easy. We'll just look at not C or B and flip all of the digits from 1s to 0s or 0s to 1s. Okay, so the entire piece here has been taken care of. Finally, we're going to deal with the multiplication. When we've got multiplication, that's our AND gate. But what are we multiplying this with? Well, inside the second set of brackets, we've got not A and B. So first we need to sort out not A. And then we'll look at what happens when we look at not A and B. And then finally, we'll take not C or B, its negation, and not A and B. First things first, let's look at not A. Once again, I'm only interested in the column that shows me the A input, and I'm going to flip each one. Okay, well, what about not A and B? Which two columns am I interested in? I want not A and B. Remember how AND works? For AND, both inputs must be 1s for the output to be a 1. And then finally, we're looking at this entire piece and this entire piece. Again, if there's a 1 in both of them, the output will be a 1. We have an OR gate, the plus, and a negation of B, or a NOT gate. What order do we need to do those in? We'll look at brackets first, then we'll look at any NOT gates, followed by the AND gates, the XOR gates, and then the OR gates as a final one. Don't forget your regular algebra. It all works the same way. We know how order of operation works there. We're just given new operators, so we need to expand our order. Again, looking at brackets first, I have A or not B. So I need to sort that out. Between A or not B and not B, the NOT gate comes first. So the first one I'll look for is the negation of B. Then I'll get to do the OR. So I'll have A or not B. Once I have that piece, well, does the XOR or the AND gate come next? I need to do the AND gate. So then I'll have to take B and what I just found in the previous column, A or not B. Then finally, I have A, XOR, everything in the previous column, the B, and A or not B. Let's work those through one at a time, starting with filling in the possibilities for A and B, our inputs. We have an OR gate, the plus, and a negation of B, or a NOT gate. What order do we need to do those in? We'll look at brackets first, then we'll look at any NOT gates, followed by the AND gates, the XOR gates, and then the OR gates as a final one. Don't forget your regular algebra. It all works the same way. We know how order of operation works there. We're just given new operators, so we need to expand our order. Again, looking at brackets first, I have A or not B. So I need to sort that out. Between A or not B and not B, the NOT gate comes first. So the first one I'll look for is the negation of B. Then I'll get to do the OR. So I'll have A or not B. Once I have that piece, well, does the XOR or the AND gate come next? I need to do the AND gate. So then I'll have to take B and what I just found in the previous column, A or not B. Then finally, I have A, XOR, everything in the previous column, the B, and A or not B. Let's work those through one at a time, starting with filling in the possibilities. So the first one we'll look at is not B. To determine not B, I just look at the B column and flip all of my inputs as they'll give the opposite output. Now I'm ready to move on to looking at A or not B. To look at that output, I need to consider the input from A and the input from not B. And I have to remember that OR means one or the other, or both. I now have to consider B and what we've discovered in the previous problem, A or not B. This time, I'm only interested in the inputs from B and A or not B. This is an AND, or multiplication. How does multiplication work? Well, if I multiply a 0 by a 1, I get a 0. If I multiply a 1 by a 1, I get a 1. That gives us the output for our AND gate. And we're almost done. Well, finally, we have to consider the XOR. So we need to consider A XOR everything we just found in the previous column. How does XOR work? It means one or the other, but not both. And you finish your second truth table.